So welcome everyone. I'm so glad you're here. My name is Melody Birkins. I'm the director of the Institute of Arctic Studies in the John Sloan Dickey Center for International Understanding. And it is such an exciting and honor to have today with us Dr. Jeff Kerby. The talk, as you're going to see, is called Arctic Cooperation Through a Lens, the Intersection of Cooperation and Collaboration in Greenland, Canada, and Russia through Science, Photography, and Virtual Reality. So I think you all are realizing both from the wonderful photo, thank you everyone who made this for me, but also through the title. This is one of those talks that really is going to touch on so many different aspects of climate change, of technology, of work in the Arctic, of collaborations across cultures and landscapes, and all amongst the active change of all of the peoples of the Arctic, the landscapes of the Arctic. And Dr. Kerby is part of all of that, and we're so lucky to have him here. As you all know, climate change disproportionately threatens Arctic ecosystems and ways of life. And in this talk, Dr. Kerby will discuss these dynamics intimately and the vital role of collaboration across diverse communities and scientific disciplines, and how this interfaces with his work as a photographer, and I would say a storyteller and narrator for both people and landscapes. He'll be drawing from projects in Canada, Russia, and Greenland, and will discuss current challenges, lessons learned, and future opportunities in collaborative ecological research in the Arctic among indigenous community members, scientists, and other engaged stakeholders and rights holders. He received his PhD in ecology at Penn State University and was a Neukom Fellow here at Dartmouth College before moving to Aarhus University in Denmark in 2020, where I believe you're still a Marie Curie Fellow. While at Dartmouth, as I said, he was a Neukom Fellow and was also a Dickey Center Arctic Fellow. So in 2022, it is still our distinct honor to have his continued affiliation with us and helping us teach and talk with a next generation of Arctic researchers and educators. His work as an ecologist explores ecological scaling and climate change responses, particularly in the highly seasonal environments such as the Arctic. And his documentary photographs aim to reveal insights about diverse people and places that are impacted and responding to environmental change. I want to say he didn't put a lot of this in here, but just some of this was in the early parts. But as if you go and look at his bio, as he stands, as you said, he'll stand awkwardly over there briefly. He has been featured in National Geographic Magazine, including work employing drones in landscape conservation. He's worked with the BBC Natural History Unit. He's published photos and video in Wired, Geo, The Atlantic, and several news outlets and television series. In 2017, his work was shown at Visa pour l'Image, International Festival of Photojournalism at Perpignan, and was the winner of the Banff Mountain Film Mountain Photo Essay Grand Prize. There are several other awards that he brings to his work, and the fact that he's going to share all of those media styles and that knowledge with us today about such an important place and such a dynamic and changing place, the Arctic, is really an honor, and we're actually hoping, I think he's going to also work with some of our Arctic innovation scholars next week. So the generosity and knowledge of Dr. Jeff Kerby is what I hand to you right now. Thank you, Jeff.
Thank you so much for that really kind introduction, and it's my absolute pleasure to be here right now, especially to give a talk that I don't normally get to give. So usually I'm giving kind of a scientific presentation. This will depart from that a little bit, but it comes from that lens and my background as a scientist. I think that way, I've been trained that way, and I pay the bills that way. I study Arctic ecology, and what I want to do is give you a sense of that motivation before we go into three kind of short examples of collaboration that I'll talk about from the Arctic, focusing on photography and imagery. So to get started, we can go north from New Hampshire up to the Arctic. And there's a fundamental basis for how this system really works, but you can't see it in a way, but it's hidden beneath the soil. And this is a map of permafrost in the Arctic. It's showing the continuous to discontinuous to kind of sporadic permafrost, but it underlies nearly all of the land in the northern part of the world. And what we have here is frozen soil, a mix of rocks, ice, and particularly organic matter that accumulates and stays there. And it's very different than the kind of soils that you might find in the rest of the world, where the same processes are feeding it. Organisms live, leaves fall to the ground, animals go through their life cycles and die. But unlike in other systems where microbes might break this down and send it back up into the atmosphere as CO2 or methane, the short summers of the Arctic end and cold periods come back, and those microbes don't have a chance to really get at their business. And that carbon stays in the soil, it becomes part of the soil, and it freezes there. And this happens year after year, decade after decade, century, et cetera, through millennia. And what you get is a carbon pool. So this is a graph that kind of brings the Arctic into focus here. If you look at latitude on the bottom and the carbon stock, this is just in the first 2 meters of the soil. You can see at the high latitudes of the Arctic, you have a substantial stock of carbon, soil organic carbon, that is not really matched by anywhere else in the world. So 33% of all soil organic carbon in the soils of the world is in the Arctic, despite it only being about 15% of the land. It's twice the size of the amount of carbon that's in the atmosphere. And as you can see, that's coming from a pretty small kind of sink of carbon where vegetation is pulling that out of the atmosphere. So this is a long-term process. That's all well and good. Okay, there's a lot of carbon in the soil of the Arctic. But the Arctic is one of these places that's experiencing disproportionate rates of warming and change. And so this is a figure made by a colleague that I actually met on Twitter. I thought this is one of the most kind of visually appealing ways of showing this. This is the Arctic of the future, and not the distant future, maybe even 20 years from now. You can see, he called this Mount GCM up here. And so we're looking at maybe 15 degrees Fahrenheit warming under a RCP8 scenario, which is kind of the high-end business as usual warming. But regardless of how you look at the future of the Arctic, it's going to be much warmer than anywhere else in the world in terms of the rate of change. And that's amplified by the loss of sea ice that kind of goes back and forth, accelerating that. So if you have a system that is built on frozen ground and storing all of this carbon, this potential source of material for greenhouse gases, and you start heating it up, it can have global consequences. As those microbes then get access to have a chance to start breaking down this material and sending it into the atmosphere, either as CO2 or methane, depending on the scenario. As the Arctic warms, glaciers and ice sheets start melting, contributing to sea level rise. As ice disappears, it doesn't protect the coastlines from wave actions, which can erode the permafrost-rich coasts. So it affects you and me here. But it directly affects the well-being of people and the functioning of ecosystems in the Arctic. This is a direct effect on livelihoods, people that rely on these ecosystems for sources of food, for their general economy, and their history. You don't normally build buildings in the ocean. It's not a good place to build a building. But when you lose the protection of sea ice from storm surges or rising tides or can percolate through porous permafrost, you're living in a fundamentally different condition, and one that you didn't cause. The majority of these contributions to greenhouse gases and the warming we're seeing in the Arctic came from folks living further down south. So we have a pretty good scope of how wide this contribution from greenhouse gases emanating from permafrost is going to look like over the next century. It's got some pretty big bounds on it, but we know roughly what it might be like. But there's some factors that we don't fully understand, and vegetation is a big part of that. It can start acting in the opposite direction to pull carbon out of the atmosphere, which reduces greenhouse gases. Or as things warm up, plants can go vigorously and start changing the way that snow or other temperature-affecting aspects of the environment influence the soil beneath it. And this is where I spend a lot of my time unpacking this complexity. And that's the lens through which I often think about the Arctic. And you can make simple narratives about this. If it gets warmer, it gets greener. And that's essentially true. And what this is a map showing this kind of relationship plotted out spatially. So this is a metric of how green it gets in the summer. And if you go through time using kind of our historical data sets, you can see the Arctic on average is getting greener and greener every summer, which you would expect if plants start growing more vigorously. This is mapped out by pixels. You can see some parts are getting much greener than others, and there's some places that are even getting browner. But on average, you're seeing this pattern emerge. But I just want to caution you that these pixels are each about the size of Manhattan. And it was incredible that they could design satellites in the 1970s to measure this sort of stuff. But there's a lot of limitations to trying to unpack that information. We have much better stuff now, but it doesn't tell us about change. We also don't have a lot of information about what is happening on the ground. This is a map of all of the observation sites that have been published in kind of Arctic ecology literature. And blue areas are areas where there's like kind of one observation or very few. Red are areas of lots of observations. So you can see there's a highway in Alaska that a lot of people like using for research. And there's parts of Fennoscandia that are really heavily studied. But beyond that, there's a lot of gaps in our understanding of what's happening beneath the pixels, kind of the real world consequences. So I want to take you there. I want to take you to a place where we're actually studying the interaction between vegetation, herbivores, and the people that make their livelihoods in this place. And you'll notice this is called research paused, and I'll talk about that. So it's Yamal, Russia. This is northwest corner of Siberia. It's 2017. I'm in a helicopter with a bunch of people that I don't know very well. It's extremely hot. It's about 85 degrees Fahrenheit, which is up there with the limits of what has ever been recorded in this part of the world. Right before we got on, the helicopter pilot said we had to dump about a third of all of our gear because helicopters don't work as well when it's very hot and very humid. Not normally a problem in the Arctic, but it was kind of an auspicious start. So I'm looking out the window and I see all sorts of things on the environment beneath me. These things that are going on within a pixel. I see algal blooms just pumping in these lakes, these very cold lakes. Like, all right, that's not what I expected. I fly past all sorts of natural gas infrastructure. This is where about 20% of Russia's natural gas comes from, could be going up to about 40% in the years ahead. So there's a huge amount of investment in this part of the tundra, which normally you don't see tundra looking like this. I start seeing plants, patterns of plants. Okay, we have shrubs that are clearly following these wet areas in the river, maybe these old disturbances. And then you see kind of more grasses in other places. These are the patterns where it's like, oh, maybe we expect stronger responses in wetter places when it's warming. You see parts of the landscape that are collapsing into themselves, creating new lakes, or in other parts, lakes that used to be lakes that are now drained and empty as the soil beneath them kind of becomes porous. And then you see things like this, thousands of tracks that were created by reindeer as they move through this wet soil towards these shrubs. And that was kind of like, okay, we're going to a place that has all of the pieces right now. So the helicopter carefully dropped us off really quickly because it was worried about sinking into the mud because it was so hot there. And then we set up our camp and settled in for the night. So this is what it looked like. This is about as dark as it got. But this was in coordination with our collaborators. This is a Nenets camp. So the Nenets are indigenous people that live in this area and have herded reindeer for a very, very long time. And this has remained intact throughout the Soviet period. And there's a lot of kind of interest in how policy affects their lives from them. There's all this gas infrastructure that's going in here. How does that affect reindeer herding? And so that's something that some of my colleagues have come and worked with the Nennets with for a very long time. This is Bruce Forbes, who's also strongly affiliated with the Dickey Center. And if you want a lot more information about this system, there's a fantastic YouTube video of a talk that he gave here that I recommend you check out. So he's there coordinating, and this is Nina Meshtub. She's an anthropologist. And so we're not just studying plants here. I came primarily for that, but this is a project that's looking at all aspects of the social ecological system. And it's not a relationship with the Nennets that started yesterday. I started back during the Soviet period when Bruce, I don't know how he got permission to go out here, but he was up there in the early 90s, kind of as things were just getting started with building this gas infrastructure, like let's lay a road to the future. Извините if I didn't translate that perfectly, but you can see, this is right in the region where we're headed. And so I'm using pictures right now to represent the people that are part of this collaboration, but you'll notice I haven't really showed much about the Nennets except for some of these faraway pictures. And that was a point of discussion, actually, I had right before this talk. The situation in Russia is very tense at the moment, and we don't know exactly if it would be great to show all the people that we've worked with. Probably not an issue, but I'm gonna take it very cautiously and not do that because this is a stream talk. And so I just want to acknowledge that I'm underrepresenting the Nennets in my images right now, and that's frustrating, but I just wanted to let you know that. Because when we're designing our experiments, we collaborate very, very closely with the Nennets because they have so much knowledge about this system. They can tell us where we should be putting our sites, where interesting things have happened on the tundra. We're only there for a few weeks. What issues they're concerned about. And so we work with them and then use that to inform our policy of where we're putting our experimental units. So we can study the impacts of one of the largest kind of reindeer concentrations that you see anywhere on the tundra. So this is great for understanding this region and feeding back on this region, but also understanding how these interactions unfold across many different parts of the Arctic. So we figure out where we're going to put stuff. We start measuring the before part, what plants are there, what's the community look like, and then we start just pounding metal rods and making fences. This is to keep out rodents, and then hares, and then eventually bigger ones to keep reindeer out. And so what we do is you set up an experiment after you've got a good baseline, and then you come back a few years later and you get to see what the effect is of taking reindeer out of a part of a system and comparing that to what's next door. And we do this in different parts of the landscape to start to unpick some of that complexity. Yeah, so you just let them do their magic. And whether that's reducing shrub cover, which is how people often think about it, or maybe not reducing shrub cover, you can find out when you come back. Is it affecting all different parts of the landscape? Yeah, that's why we do experiments, because we have lots of ideas, but it's useful to have data sometimes. So that was our 2 weeks. We did that work. Many other things happened that I skipped over, and we're ready to go. Because of this heat wave, it changed all the pressure systems, and we got this huge windstorm that came in. It started shredding our tents. This is one of our colleagues saving that big tent. This is Bruce looking really happy about his tent being destroyed right now. And it actually whipped up forest fires that were happening right kind of where the helicopters were taking off from, so they couldn't come get us because the entire city was covered in smoke. So we had to spend another couple days there. Eventually, they got us, and we could see the fires kind of billowing in the distance. And that's where this story ends right now, because we were supposed to go back there 2 years ago to figure out what happened. As you know, COVID was kind of something that happened. But then we moved forward from that. But now with the political situation, with Russia's invasion of Ukraine and all of the kind of ripples of that, We can't go here, and it's also extremely difficult to even communicate and collaborate and know what is allowed or safe or legal or illegal with all of the agreements that we have. And this is a huge challenge to not just this project, but to bigger projects that seek to synthesize information like this and build the kind of coordination that's needed to tackle these large challenges like the changing Arctic. So Bruce Forbes, again, this kind of former or maybe continuing Dickey associate, is chairing this project. And it really takes these pieces, puts them together from Russia, Fennoscandia, and various other places. We can't do the field part of Russia right now, but we're still working to build as much as we can. It's frustrating, though, when, I don't know, 40% of all tundra is in a country that you can't work with right now, for many reasons. Sometimes you need more information than even coarse or rough satellite pixels can give you. And so we can find insights from all sorts of different places. So I want to start, though, by pointing out a little bit of diversity in Arctic landform in general. This is that same kind of greening map. You can see these Manhattan-sized pixels a little bit better here. And then this is where I was this summer on an island called Eleu in northeast Greenland. The pixels didn't even map on this part because this is an old. There's other satellites that work fine, but there's limitations with all of them. So this doesn't look like Yamal. This is mountainous. There's not a lot of vegetation productivity, and no people live here, and they haven't lived here. This is a part of the Northeast Greenland National Park, the largest national park in the world, and there's usually just at peak a few dozen people in this whole area doing either security, research, or government work. That's us. We took a little hike up to the top of the hill this summer, and yeah, again, it's not a flat, ice-rich permafrost landscape. And so what this region is, though, is a really important kind of outpost in understanding how all sorts of environments like this type of environment are responding to climate change. There is a huge ice sheet in the middle of Greenland that has the potential to pump all sorts of fresh water and raise sea levels in the world, and have widespread impacts on large populations of musk oxen and also potential sources of methane in this region. So a lot of this vegetation productivity map that you see here, again, this is that kind of greenness index. This is the northeast coast. You can see that in the red areas, and that's where this like sort of higher vegetation productivity, there's not very many of them. There's like a couple out here, there's some up here, and there's like one down here. Up here is Zackenberg, which is kind of one of the premier research stations in the Arctic. It has revealed countless insights about how Arctic systems work. It has been in operation since the early 90s, and it's just an absolute hub of knowledge. But it's only one place, and there's not much infrastructure in the rest of this region to understand how that knowledge translates and how it looks. Also, the kind of historical background information of Zackenberg doesn't go back that far. And so what we can do is take advantage of other resources that exist. And I don't have time to go through and tell you the full story of a very interesting person named Louise Arner-Boyd. But the short version is that she was an extremely wealthy heiress who inherited a gold rush fortune. Most of her family died while she was relatively young, and she decided to spend her fortune mapping and bringing scientists and taking photographs of the Arctic, and she did. She spent her entire fortune on this and died pretty much not rich anymore. And her legacy is a very interesting one. So she's a filmmaker, photographer, cartographer, and also just a gender norm buster in the old boys club of kind of Arctic exploration of this time period. And what she did is she left quite a collection that we can take advantage of. So these are some of her pictures. They were eventually ended up at the American Geographical Society and then at the University of Wisconsin-Madison. And she published several books, and this is a map from one of her books showing the routes that she took. And so this is that big hill that I was standing on earlier, where our research base was. And this is that big red spot in the lower kind of part of the map I showed you before. There's a lot of vegetation activity going on there, but we don't know much about that place. But she's been there, and she's taken tons of pictures about 100 years ago, or 90-something years ago. And then she kind of made a rough map on a bed sheet, which is also really helpful. It's not completely helpful, but it's pretty helpful. And so this is information that I didn't know about, but the scientific director of Zackenberg, Torben Christensen, and Peter Schmidt-Mickelson, who is a former Sirius Patrol member, the people that patrol Northeast Greenland on dog sleds, and he's also an author and historian. They knew about this, and they kind of talked with me and were like, well, we might have a day or two to go to this site if we're lucky. Like, do you think we should go give it a try? We're gonna have to be really efficient with finding these very difficult to find repeat photographs. I said, sure, but we gotta give ourselves a chance beforehand. So we were able to explore this place before we went there. I downloaded some of the more modern satellite imagery and made it into a 3D landscape, and then you can kind of just walk around and try to make sense of where you are. And so if you see a picture like this, and like, all right, that looks like a pretty memorable view. Where can I find that in this landscape? So you can look at the bed sheet or some other resources and try to figure out where maybe it is. And then you start positioning yourself until you're like, okay, yeah, this looks pretty good. And then you can write down the GPS coordinate that the mapping program tells you at that point, because they didn't have GPS back in the day. So yeah, you just do this for a bunch of photographs and hope that you got the right landmarks. And yeah, you can kind of point the direction that it's looking at. And then you go out there with some printed photographs, and yeah, you find a few of them. So this was an incredible feeling when you're standing in the same place that this person that you've read so much about, that you like, yeah, and you get to see it, and like the things that really pop out are just how similar some of the pictures are. You're like, oh wow, yeah, pictures, they're powerful. Then you can kind of make them match by warping them a little bit for more quantitative comparisons. And you get early August 1931, and you get early August 2022. And you can kind of make them look similar and then start trying to play the what's the difference game. And this is where you start getting quantifiable information about what's happening in the Arctic. So we can zoom through a couple of these. This is 1931, and this is 22. So all right, we can go back and forth. You can see that there's a lot of ice missing here. But for the vegetation-minded folks as well, there's been a lot of kind of infilling and change in some of the shrubs in the foreground. I'm sure you all noticed that first. You can see erosion factors, so this part of the landscape has moved back, and there's also a lot of infilling of the shrubs up here. There is a landslide that happened sometime in the intervening century in this place, and we see these landslides all over the place, perhaps related to freeze-thaw cycles. Ice dynamics and patterns have changed. If we zoom into this mountaintop, you can see there's a lot less ice up there than there used to be. So this is a start. We're starting to quantify all of this. This is the first time we've shared any of this information. And there's all sorts of other ways you can perceive it. So I also made 360 panorama photos of the places where we found some pictures. So all these three pictures are in the view of the scene right now. And you can put one of these VR headsets on, and this is just a screen recording of me kind of like looking around in the VR headset. So yeah, do you see these three pictures? You can kind of go through the process. I think this is a way to give people a broader sense of the context of the images and also just understand the process of the science. So there's also some education opportunities here. So yeah, we were aiming for a couple days there. We got about a day and a tenth until some polar bears came. These polar bears we saw on the way, so that's why I got a nice picture. The polar bears that made us leave. It wasn't like a dangerous situation, it was just a situation where our margins for safety were better if we left. So it was a place where there was like a valley just full of musk oxen, foxes, hares, and polar bears, stuff that you don't see as often in these other parts that I've been to. And so yeah, we're working on it. And I think there's a lot to be done still. There is a complex legacy of what it means to be an Arctic explorer. I was talking about the Old Boys Club, or like how many discoveries there were, or how can I self-promote myself. That was a big part of being an explorer back in the day. Well, at the same time, it also produced some collections and sets of information that remain very valuable right now. One of these extremely valuable collections is at Dartmouth, the Valdemar Stephenson collection. So I was in there the other day kind of trying to see if these two cross paths. And sure enough, there's some notes in between the two of them. They were going to meet up at the Ritz, but he got a headache, so he sent her a telegram that he couldn't go. There's a lot more digging to be done in this archive and in others to broaden some of this work. But this is kind of a visual-focused thing. There's a complement of this work to much bigger projects that are happening in this park in collaboration with many agencies. So yeah, I just want to make sure that I give them their due as well. And so let's head to our third place. And this is in one of the regions that is kind of greening most prominently. This is like kind of the North Slope area of Alaska and Canada. And there's one island in the Beaufort Sea in this area. And it's a very kind of important cultural hub. It's called Qikqtarjuaq. It's also called Herschel Island. And so this is a project that's working as a way to kind of make some of these changes that are happening in the Arctic, these things I've been talking about, more accessible to different stakeholders. And so this is, again, a very collaborative project. But to give a bit of background, this is the kind of settlement area on the island. You can see it's very low-lying. That is the oldest building in the Yukon right there. But there's also many other buildings that you can't see because this is a place that has been used by the Inuvialuit for many centuries as a really important hunting or stopover ground. And so there's all sorts of sod houses, some of which have been kind of reclaimed by the ocean as coastal erosion has come through here. Then this was a big hub in the whaling period. There were over 1,000 people living on this little spit of land during the kind of turn of the 19th, 20th century. And later on, it was also an important hub for kind of explorers that are looking to either start or end the Northwest Passage. So Stephenson was here too. I found a bunch of pictures that he took where this harbor was full of boats in the library. But it's an island that's built completely on permafrost. There's very few rocks anywhere on this island, and it's kind of a vibrant green and greening place. You can see a herd of muskoxen here for scale and some of the kind of erosion that's happening. It's also kind of right across the spit from the core porcupine caribou herd, which is one of the largest in the world. But you can also see signs of kind of oil infrastructure in the background. So this place has a lot of cultural importance and a lot of interest for historical reasons and a lot of interesting scientific things happening, but it's really expensive and difficult to get there. You can take a 10-ish hour boat ride through the Mackenzie River Delta from Inuvik in a small powerboat, which if the weather turns could turn into several days or worse. Or you can take a helicopter, or you can land a plane, a small twin otter on the island. But that gets very, very expensive. And so some programs allow people to come here from many different communities. So this is a photo kind of from the Elders and Youth program, which brings youth from Inuvik and Iklavik with elders from those communities to have an opportunity to be in a place to hear some of the heritage that is associated with it. But again, this can't serve as many people as it could because of the costs involved. And the same is true for interested tourists or for researchers that are trying to get there. It's a very expensive place to go. It's also a place where there's a long-term collaboration between the park rangers, and this is head ranger Richard Gordon right here, and this is an ecologist that I've worked with for a long time, Isla Myers-Smith, who has been working on this island for decades, to kind of reach the mutual interests of research, monitoring, and preservation programs that are at the core kind of rationale behind the Yukon Parks designation of this place. And so there's been information produced, and I first came here in 2016 with Isla to kind of help with some of the drone work. But there's science studying what's happening below the ground. This is a permafrost probe that you stick into the soil to measure how deep the thaw in the active layer is, and work above ground. And there's all sorts of environmental changes that are happening here. So here's just a couple of the kind of simple narratives that we could talk about between thawing permafrost, threats to heritage, shrubs taking over, or eroding coastlines. But as we were thinking about all of the scientific work we've done during COVID lockdown, because we had plenty of time to think about that, we also realized that we had a lot of drone data, which has multiple other uses. And we also had some problems that weren't going away, namely accessibility to the island and the real challenge of communicating change beyond kind of the human perceptual scale. I can show you a picture of something big and tell you it's big, but it doesn't feel the same as if you were standing next to it. I mean, I guess that's why we still go to the zoo and things rather than just looking at pictures. So these were challenges that we had. We're like, well, maybe we can use our drone data to create a immersive environment that allows you to achieve some of these things, and also an environment that we could show change in that is relevant to the human scale of perception. So we put together a grant initially to National Geographic Society that brought together Richard Gordon, who's the senior park ranger, and Annika Trimble, a northern educator in Inuvik, with Isla Gurgana, who was her grad student at the time, who's now a postdoc, and a guy I met at National Geographic, Martin Edstrom, who runs a company that is producing immersive content. So we had some data, we had some time, and now we had some funding, which is all well and good, but what do you do? How do you make something, and what are the solutions to those kind of general ambitions of accessibility and getting different voices representing the changes that are happening there. So we kind of narrowed it down to different things we wanted to focus on. So I'm going to talk about the thawing permafrost chapter right now. And so each of these chapters will have a different voice, whether it's Richard or Isla going through. And so this is what one of these permafrost thaw slumps looks like on the island. This is one of the largest in Canada. And a basic objective would be great if people understood that carbon is stored in Arctic soil and that huge changes in the landscape can happen at human scales, even just over a couple of years. So yeah, this is a big place. You're going to remember that, hopefully, now for the rest of your life. And it changes relatively quickly. This is 3 years of data from 2016 through 2019. And there's a soccer field for scale. So yeah, it is a pretty big change that's happening over not so many years. But what if you could stand on top of that as it was changing? Maybe you could look in the distance and see what it looks like and remember it a bit better. So these are some earlier renderings of what this looks like. So this is a rendering made from drone data that has then had a caribou added to it and some touching up work by Carl Frederick, who's an excellent animator that we work with. And I think I have a minute, so I'm going to try something risky here and exit a presentation in the middle of talking about it, and then go into a website. Okay, so this is a newer version of what this VR experience looks like, and you can see this in a headset. It feels much more realistic there. And you can navigate through this. We have some changes to make. There aren't rocks here, but it's an iterative process. And you can get up on top of the permafrost slump and get closer out towards the edge. And then we can start animating how it changes through time. And when you're in it and you have all the sound, and we're even finding ways to add smell to this, it's a more memorable and immersive experience when you can look and see in the distance how big these changes are happening around you. So this is 2017, and that's 2019 right there. So if you're floating in the air, you might remember that. Okay. There's also many other dimensions to this. So with threats to heritage, this is something that Richard confronts in his job every day. Part of his mandate is preserving the park's character, but how do you do that if the environment that it's built on is fundamentally changing, if the soil is becoming more porous and sea level can percolate up through it, or if it's not protected as much? So there's challenges there. And this is another group that we reached out to who's done a fantastic job of this already. So I just wanted to make sure that they got some due here, who have gone through and they've done terrestrial LiDAR scanning of all the buildings. So they have all sorts of excellent heritage focus already. And this is through the University of Calgary and the Yukon. And we're talking about ways that we can bring that together to kind of show future scenarios or scenarios that are happening already. So this is a very crude rendering. Martin, the guy, told me not to show this because it's not nice enough. But it shows the example of just what you can do. You can create different contexts that are real or that have happened at time scale. So I'm sorry, Martin, if you see this, but hopefully the point is made. I put early stage draft on the bottom. So this is an iterative process. We come up with these basic ideas of what the stories can be. We figure out why that was a terrible idea or our hardware is messed up. Luckily, we're much more efficient at this because of our work with Martin and his colleagues. And then we get feedback from all stakeholders and inputs, because the ultimate use case for this is at the parks office and in schools, in Inuvik, in Aklavik, to give people a chance to go there and hear the voices of researchers or the park rangers that are dedicating their lives to this. And once we kind of zero in on that, then we can find ways to share it more broadly. But it's absolutely an iterative process that is aligned to its purpose. And we're in progress with that right now. So hopefully that was a hopeful kind of sneak peek for its potential. There's all sorts of potential for kind of collaboration as well when it comes to education and research planning with these tools. So I think this is early days for this. So to kind of sum things up, there's simple narratives about change that are based on true things. And it's a really useful narrative sometimes to talk about when the Arctic heats up, things green up and plants respond, things like that. But there's an immense amount of diversity within the Arctic, within a single pixel, not just of ecology, but of kind of societal and cultural diversities that require really nuanced and targeted understanding. And this is a task that's bigger than any research lab. This is something that benefits from working across groups, not only within academia, but includes different knowledge holders across the Arctic, whether it's indigenous communities, park rangers, and other stakeholders. So this isn't a surprise that you benefit from having a more diverse and engaged collaboration. But a big part of that is being committed to that and being effective in how you communicate, which is hard and is something that it takes effort and learning. And then, in a broader sense, things like COVID happen and no one planned for COVID. And then the Russian war in Ukraine, it can have widespread impacts on these collaborations. Sometimes we don't know what the outcome will be, but they are there, and we're trying to make the most of it during a time period where we really need to act. And this has an impact on these broader kind of national level cooperation and kind of legal planning that happens. So at its end, this has been a very image-heavy talk. I started out with some graphs and talked about carbon, so hopefully I didn't, get you too riled up with that. But then we got into the images, and I think it's important to say, they're a very flexible tool when it comes to communication, but also there's a lot of potential for research and education. So thank you.
Thank you so much, Jeff. And yeah, you've covered so much. And you've brought, actually, what I think you're hearing is this way to have the imagery, not only the education research, but actually bring us closer to these issues. And because the Arctic is far away, not all of us can go all the time. But there's so much happening there, 4 times the rate of warming, some of the latest say. And it may just get worse. But we need to think about it. We need to think about the people we're engaging with and the landscapes. And if we can't go there, some of these immersive ways of being part of it, and thank you for such an incredible presentation, make you feel there. And I've done the VR, by the way, and it makes you're watching the erosion happen in front of you over the years. It's really, really powerful. So the students are going to be very lucky to have these tools. I'd like to open up to questions. Raise your hand and we'll bring you the mic.
Thank you very much. An excellent presentation. I'd be curious to understand a little bit more about the Russian collaboration at the beginning.
Yeah.
And appreciating that that's on pause now.
Yeah.
Is there a timeline after which that work is not relevant? And is there any chance by being there longer, it may actually be more fruitful at the end, the silver lining?
In terms of the scientific experiment that we set up, if the fences maintain their integrity, then it will still be useful at some point if we can go back. Given that it's in permafrost and there's a lot of snow and drifting going on in some places, I don't know how long the fences will stay intact. So it'd be better if we went back sooner and then kept them up and then could check again in the future, because having that time series is great. But we'll try to make the most of it if the opportunity arises, but I don't know what that would look like.
Hey, Jeff, thanks for that. In your aerial image of that island with the settlement on it,
Yes.
it looked like there was, maybe I was wrong, a bunch of driftwood logs or something like that.
Yes.
And some of them seem to be used in the construction of the buildings. Where do they come from? What's the deal with that? They're not local, I assume? Do they drift there? Or are they left over?
Absolutely. So my understanding, and someone can correct me on YouTube if I'm wrong, is that those logs come from the Mackenzie River and kind of outflow from there, and then they drift over to the island. Some of them might be from much, much further away. I know that there's interest from dendro-ecologists, either at this site or other places that try to find really old wood from Siberia in parts of either North America or other places. And I think that even inspired Fridtjof Nansen to get his ship locked in the ice to drift to the North Pole, because he found some driftwood from Siberia on the other side of the Arctic. He's like, oh, easiest way across the Arctic is just drifting. So it could be from really far away, but I think most of it's probably from the Mackenzie. Yeah. Oh.
I have a question. So what do you think are the most important things when it comes to the important things that you've done that helped you build long-term relationship with the indigenous communities and help them feel comfortable about their lives and knowledge being documented and shared to the public? Like, what are some of the things that you've done that you feel is very essential to, successfully communicating with them?
Yeah, well, I think the success stories that I've seen have been, I'm not saying this is the only way, but is having a long-term relationship. So where you build an ability to communicate and to trust and to understand what everyone is interested in and find ways to mutually benefit. When you have more time in your career as you get older, like you have a chance to have those longer relationships develop from the start. From my experience, I've been able to work with groups that have developed those relationships. And so I try to bring as much to that as I can, because I, on an individual level, benefit, but I'm aware that I need to contribute to all collaborative members when I do that. So I would say that. Oh, yeah.
The disappearing carbon stocks in Canada you were showing, it's amazing.
Yeah.
Thinking about the productivity of plants there now, even if, every year it stayed, it would take a long time to accumulate that much carbon. How old is the carbon in those stocks, or did it come from somewhere else?
So I do not think that the layering and carbon in that very particular permafrost dust lump came from the plants that were chugging away on top of it there. If you look at this island from a satellite map, a couple things stand out. It's the only island around, which is kind of weird. It's like, why is there only one island here? And when you're on the island, you notice that there's, as I said, like not a lot of rocks or anything around. It's just a lot of ice-rich, silty-looking soil. So I think there was a big ice dam many thousands of years ago that existed on the mainland that broke. And there was a huge outflow of sediment that came from that time period that created this island, which probably wasn't an island always. And then on top of that, you get inputs from the plants. So I have no idea how long it would take in that particular case for plants to build something up like that. But they could. I mean, if you look at the Batagaika crater in Siberia, which is much, much larger than the one that I showed you, there's no, I think that comes from plants there. So permafrost can go deep, and it takes a long time to build up.
Okay, I take the prerogative of the last question, which is, when will you come back and show us the VR in its, when can we schedule that? When do you think that's going to be ready for showing?
Yeah, it's been nice to have the ability to share some sneak peeks with the understanding that this is kind of a work in progress. When it comes to really having the narrative, first we have to make sure it passes muster with our collaborators, both on the scientific team, but in Inuvik as well. So after that.
Well, thank you. And honestly, it's such a wonderful way to marry science and imagery and education and research and detective work all in one. So I do hope you come back with all of that put together, and we can maybe schedule time for people to come and do it. And thank you again, Dr. Jeff Kerby. Thank you all for being here, and have a wonderful evening. Take care.
Thank you.